Hello, everyone who is watching again our podcast or even listening today. This is your podcast, Testing Minutes, where we talk about testing, brief, and to the point. And today we have a special guest, I would say, in our podcast. But before we introduce our guest, you know that today your host here, it's me, Artem and coach.
And it's me, Alexander Romanov, software engineer and test in IOG.
And today our guest is Michael Bolton. And I have some script written about introduction, Michael. And is a consulting software tester and testing teacher who helps people to solve testing problems that they didn't realize they could solve. And also, he is co-creator with creator James Bach of rapid software testing and methodology of testing that focus on the skills and the mindset of individual tester to perform excellent testing more quickly and less expensively in a way that stands up to scrutiny. And welcome here, Michael.
Thanks, Artem. Thank you, Oleksandr. Nice to be here.
Like when I start to prepare into our episode, and like I don't know, like maybe several years ago, I would think about, okay, now I have like 10 years of experience in software testing in IT in general. And when I read uh, about your section on your website, I was like, oh my God, people's like, I think from the beginning of our craft and teaching us to do this craft, and you're already teaching the rapid software testing for more than 20 years already. But it's always interesting about how it started. Maybe you can tell us small history of rapid software testing and actually what led you to develop this approach or framework. I don't know how would properly say about what is rapid software testing.
Well, that's a change of subject there, of course. But let's start with that because that's a good place to start. Rapid software testing is a methodology. That means a sort of system of methods. Think of methodology like ecology, something that describes a system. But it's a system of methods and approaches for testing in the fastest, least expensive way that still completely fulfills the mission. That's what we aspire to. Now, of course, never always successful at that. But that, if you like, is our bias. We want to provide fast, reliable, relevant, unfussy feedback to developers and managers and other testers and organizations so that we can continuously be aware of whether the product that we're building or the product that we've built is the product that we want. Now, by we, I mostly mean the business. What the business is building is the sort of a goal that we serve. And that, of course, includes making things shining light on how actual users will experience the product. But also it's important. There's a couple of discussions that have come up on LinkedIn just in the last day or so. It's important for us to realize that while the user is the person for whom we are building the product, we're also building it for other people too. We're building it for the ops people. We're building it for the customer support people. we're building it in a sense for other developers and other development groups that will come along after us. It's why we want to, for instance, test the user experience of using the API, which the API is a means to an end. And of course, it's always oriented towards some end user, but there is an intermediate user in an entire system like that. And that is the developers who are going to be using the API. Anyway, another aspiration is to test in the interest of anybody who might matter, anybody who might be affected by the product, anyone in our organization, and certainly the customers and the people upon whom the customers depend, our products customers. For instance, people on the other side of the check-in counter at the when you're getting on a flight someplace. The person who's using the product ostensibly is the person who's sitting in front of the screen and the keyboard and so on and facing another person across a desk or a counter. But we're building software for that person too. So it's not just the people who are using the product, but the people who are affected by it. Okay. That's a part of what rapid software testing is all about. It's fundamentally about learning about the product, learning about the domain in which it is intended to fulfill a service. It's about learning quickly and delivering the fruits of that learning and in an ethical and responsible way to our clients. That's what rapid software testing is about. Now, your earlier question was, how did this all get started? It started with James. James was presenting and delivering a class that I think was originally called Heuristic Risk-Based Testing. This is how you can tell that we're not marketers. It might be worthwhile mentioning what a heuristic is. A heuristic is a way of solving a problem that can work, but that might fail. Everything in engineering, everything in testing is based on heuristics. And testing is all about examining risks. So this was very much a case of sort of truth in advertising. But it wasn't as snappy as all that. So a few years later, James changed the title to rapid software testing. Now, why was he teaching this class, or why was he creating this methodology? Is because in his experience, all the stuff that was in the books about testing, all the stuff that was being presented at testing conferences, all the magazine articles, not all of it, but a vast amount of it was weird and useless and slow and ponderous relative to the context that he was in, which was in at least, that he had been in. Kids games. He was a tester at Apple Computer, and he turned his work to compilers and support for compilers and support for developer tools at Borland. Now, in parallel to this, I was working at a company called Quarterdeck. James and I didn't meet until after I was out of there, but I too was working in mass market commercial software, and I was experiencing the same thing. Our products, operating system level memory management and multitasking utilities. We also did an antivirus product. We did an installation and uninstallation product. And around me at the same time, the company was working on an implementation of the X window system for DOS, where we managed to turn DOS programs into X window clients. So you could have any kind of program running anywhere on any computer and have display and keyboard services handle from what was called an X server. Is kind of a little confusing the language of it, but the service that was being provided was keyboard and mouse and display. Our experiences were inconsistent with all the formalization stuff. You can see it in a lot of the books behind me here. All the very heavily formalized mathematical, uh, formulaic stuff that was taught in academia, but also it wasn't exactly jibing with what at the time was called the total quality movement. People who their take on it was, if only we tell those naughty developers what to do and make sure they'll get it right, there won't be problems in our products anymore. Then there's still that's actually in resurgence these days. It's a pretty weird thing. Anyway, James was teaching his class. I met him in 2001. In 2003, he contacted me saying that he had more work than he knew how to handle. And he also wanted to put some exercises into the class. He was kind of into an exercise drought. So I became a co-author. I started teaching the class in 2004. So that is, as you say, 20 years ago. I became a co-author officially of the class in 2006, and we've been working on it ever since. There you go. Long answer.
Yeah. So, as I understood, so the whole point of rapid software testing and why it was invented is that the most testing approach or description of testing approaches at that time was really not suitable for new software and new software models. So it was like for 70s, 80s, 90s, like early 90s models.
Yeah, maybe, but a lot of what we were looking around at us and surprise was it came about in the 90s even. It was influenced on stuff from the 70s and 80s. Remember, not very many people were computer programmers until 78, 79, 80, when the personal computer, the home computer, started. In fact, the home computer started before the personal computer. The IBM PC was released on the 15th of August, 1981. Computers were great big things, or at least things the size of a desk, not the size of a desktop. In those days, the idea behind software development, because changing the product tended to be slow and expensive, you had to recompile the product to get it working, machinery before the 1980s was expensive. Well, that flipped when the hobbyist and then the home and then the business desktop computer came along. That flipped. Computer time became super cheap. Programmer time became a lot more expensive. And so the original philosophy behind developing software was get it right the first time. Be super, super careful. Review the requirements. Review the code very carefully and very thoroughly. All of these remain pretty good ideas. But what happened with testing, so it seems, was that testing was, as we observed it, overly formalized. And we still have this disease in spades today. Really, really bad disease. Creating elaborate processes by which somebody would ponderously walk through the product, performing behaviors step by step by step by step. And then at the end of that string of actions, right, provide some input, provide some other input, do this, then do this, then do this, then do that, then observe this. And if this is, if the output you get is consistent with something specified and presumably desirable, then yay, you put a little green check mark beside it and you mark it passed. Well, that is slow and expensive because you got to prepare that. Whether you're preparing it for a person or a machine, it's got to be done. And it inhibits what we think the essence of testing is, which is experiencing a product, exploring it, experimenting with it to find out things that we didn't know about it, including things that were not anticipated by these prescribed and very heavily procedurally structured test cases. We're still fighting that today. It's remarkable how persistent this idea is. And it's based on, I think it's based on a notion that what it means to test something is similar to what it means to test a kid in a school to see whether they can get the right answer. Well, if we were hiring, let's say, a university student for a summer job, I don't think we would evaluate the student that way. I don't think we would hand the student a piece of paper with 40 questions on it, all multiple choice, or one right answer and an infinite number of wrong answers. And at the end of that process say, oh, this person is qualified to work in this job. We'd want to get experience with that person. We'd want to talk to that person. We might ask some tricky questions of them to try to see how they respond to that. We might ask them something ridiculous to see how they respond socially. But this is the thing about software too. Software is something that gets inserted into human society, and it takes the place of certain kind of tasks that humans once performed, or that humans with certain superpowers could perform. So our notion of testing is a very humanistic one because it's focused on the role of software in human society in a socio-technological domain. Mm-hmm. So that involves a lot of technical considerations, and it involves a lot of social considerations as well. The idea behind that early and more ponderous kind of testing was, does this input produce a correct output? When the context-driven movement arrived in 2000, 2001, something like that, the question we had was, does the product solve the problem for people? One of the principles of the context-driven software movement was the product is a solution to a problem, and if the problem isn't solved, then the product doesn't work. Yeah. Formally structured, procedurally structured test cases don't answer that question very well. So that's the motivation behind the way we look at the world, the way we do things.
Mm-hmm. But I have some, maybe it's connected, this question, to the whole notion of rapid software testing, but you just compared the two ways of the old way, when we have prescripted testing, prescripted test cases, and we are just doing step-by-step job, and after that we can report something, whether it works or not, according to test cases, not according to the real world. And the second thing is just explore and experience the product. But my question is, if you want to test rapidly and fast and provide fast feedback by your testing, how can we combine it with doing exploration and experiencing a product, and at the same time doing it fast enough to provide a feedback to the, let's say, to the management, whether we are good to release something or not good? So how it combines?
Well, first of all, testers don't make that decision. Testers don't make the decision whether something is good or not good. That's in my mind, that's from the tester's end, that's almost an attempt to usurp management's role. From the management end, giving that responsibility to the tester is an attempt to abdicate management's role, right? So what we are focused on is learning about the product and problems in it. Now, some of those problems might be trivial, unimportant, at which point management says, well, we're not going to fix them, or we're not going to worry about them, or the people who are affected by these problems aren't important enough to us in order for us to mandate a fix or a change to the product in some way. Some of those problems are going to be significant, and management will decide how significant they are and what they're going to do about them. Our belief is that confirmation that the product can do something is not a test. To the degree that it's a test at all, it's a pretty weak test. What we are focused on is the risk that there will be problems in the product that people don't know about, that they would prefer to know about before it's too late, before those problems get inflicted on customers, and before they start causing problems for the business that the business has to address. I mean, the CrowdStrike incident just recently is a perfect example of that. When we look at the incident report, what we see is a very heavy dependence on looking for problems that the developers, and I use that in an expansive term, it included the testers apparently as well, problems that were anticipated. And there's a whole sort of string of issues associated with that they, for example, it's pretty clear that they did not dribble the rollout of that release of that particular file. They just opened it's like they opened a big dam, and all the people downstream of it were affected by it. But the problems that are really going to hurt us, it seems to me, are the ones that we didn't anticipate. Now, of course, the ones that we didn't anticipate and address. Of course, there are problems that we can anticipate, and if those things weren't checked for, that would be pretty bad, would leave an omission. What is getting left out of a lot of testing work these days, though, is the patience and the prudence required to open our eyes to the possibility that there may be significant problems, material problems, that have escaped even a very disciplined development process. So, checking your output is a good thing to do. It helps us to identify early on reasonably easy to spot, avoidable errors that we would prefer not to get buried. That's a problem for testers too. When a problem gets buried that could have been found at development time, as the programmers are building the product, no objection to that whatsoever. What we see is this belief: we don't have time for that. But that's like saying we don't have time to drive responsibly. We've got to get to the other side of town, which if we drove in a normal and safe and responsible way, let's say that would take us an hour. It's a big city. But we don't have an hour. We got to be on the other side of town in 10 minutes. Well, you can try that. I invite you to go ahead. You need a sort of superpowered car to do that, but you'd also have to ignore all the other things that would get in your way along the way, and you'd have to ignore the law. The law is there to help constrain people's behavior so that they are sort of mandated to behave responsibly. You'd have to ignore all the other people that you might injure or kill on your way across town. But if your problem is we don't have time to get to town on the we don't have an hour to get across town, my advice would be start earlier next time and recognize the limits of what people are actually capable of. Recognize that people are going to make mistakes. Recognize that we can't have what we want right away all the time. Recognize that in addition to the candy, we got to eat some vegetables and some protein. Let's as testers, let's help to foster responsible development by recognizing that problems might have eluded even our very best intentions and our very best discipline, our very best capabilities, because that's reality.
Yep.
Yeah.
Actually, from your speech, I like the idea that we we experience with software, we learn the software, and we find the different problems in our software that we are testing. But also, I like the idea here that we also need to understand and know, I guess we should know what the problem are solved to our customer by our product. Otherwise, how you can understand the risk, how can you use heuristics here. And I think currently it's sometimes I see the problem in maybe in my students or some colleagues. They don't try to learn what kind of problem we want to solve to our customer by creating this feature or this feature or this creating component. And what do you think about it? Is it
That's to my mind, that's a beautiful observation. A beautiful observation. And that it relates to the time thing. When I look around, what I tend to see is people doing a whole bunch of stuff that doesn't matter. Elaborate preparation of test scripts, ponderous documentation, the insistence that we got to do all these tests and we've got to repeat them for every build. Well, we don't have to do that. We don't have to do anything. We choose to do things. That's a really important part of the RST philosophy. One of the things that I think more organizations could be doing that I believe would be beneficial is to have testers immersed in the world of the people who are going to be using the product. To have testers act as anthropologists, sitting with people who are going to use the product and identifying things that are going to get in their way, but also hanging out with the ops people and asking them, what would impinge on your ability to support infrastructurally what this product needs to do. Sitting with the customer service people and asking, what kinds of complaints are you getting? What kind of information would you need from the product in order to do your job more smoothly? Sitting with the programmers and learning what the programmers do. Asking the programmers what help they might need in order to arrive at a justified true belief that the product is to the best of our capacity to make it that way, problem-free. So I'm absolutely with you, Artem, on the notion that we've got to pay attention to the people who are using the product and to what matters to them. But as I said at the beginning as well, all of the other people who are affected in some way by the product or who might have some input into what the product needs to do, how it needs to be thus and so. At the company that I worked at for a long time in the 1990s, because they were there and we could chat with them, the in-house counsel, the lawyers, we had two lawyers who worked for the company, and they were actually in the offices. So we got some really, really valuable insights from them in terms of how testers could help. And as testers, we endeavor to be helpful to them as well.
Mm, like right now, I can see a lot of like things that are really like that I like in what you offer to the testers should communicate with people and learn the product. But from the other side, I can see that mm, why testers should do it, why only testers should do it. For the customers,
I didn't
okay,
say only
I
testers
totally
should do
agree.
it. I didn't
Oh,
say
okay.
only testers should do it. But what I will say is this, though. What I will say is this:
Mhm.
testers have a unique role on the development team and in the development process. No one else on the project is focused on trouble. No one else on the project is focused on the possibility that things could go wrong. Nobody else on the project has that as their guiding motivation. Now, that makes testers weird. It makes them hard to deal with because it's like it's like I guess it's kind of like auditors. Auditors
Yeah.
aren't interested in making the business profitable. Auditors are interested in the truth. Auditors are interested in risk to the business. So when we look at any kind of business that engages auditors one way or another, it's very similar to the testing role. Um, we're we're like pathologists that way. You know, so with pathologists,
Mhm.
is that why are you guys always on about disease? Don't we want to make people better in the medical business? Yes, we do. We absolutely do. But without somebody who's really interested in how things can go wrong, we won't know that well whether things have gone right. So we need that's a socially awkward position for a tester. It's socially challenging, I sometimes say, because that's a pun. We're challenging the product in a social context, in and around and for and with other people. But it's also socially challenging in the sense that it's not exactly a happy news that we're bringing all the time. And it's hard to be different from other people in that way in a social context sometimes.
I'm trying to reflect currently on my experience. And when I start testing, I was like, oh, this is a bug. Oh, this is an issue. This is a problem. I should report it. I was curious about finding problems. But with all the things, when I grew up, I can understand. Maybe I can't understand because my mind was like, oh, I don't want to find an issue here. I want to see this feature working right now with everything like mark green test cases, the scripts, or any kind of experiments I'm doing with software. And then I come back with this that, okay, we are testers. We want to find the problem before our customers will get this kind of problem. And I can see the pressure, and as you said, it's really a social position here, how the people think about what we are doing and what the result of our work.
Well, here's why I think it's important for testers to have perhaps a different line of reporting than a lot of them currently have. One of the things that happened when the Agile movement came along is that we all became one big team, right? And the testers are all in the same team, and the testers is, let's say there's a group of 3 or 4 or 5 developers and a tester in there. And come on, can't we all just get along, and can't we all work together? Well, the social pressure on the tester to conform to the vision of success undermines, it seems to me, our capacity to find problems. If you are seeking to demonstrate, to confirm that everything's okay, everything we know about psychology says that, yep, that's what you'll do. And you won't find problems. You'll be systematically looking for evidence that the product is okay. But that makes you kind of like a marketer instead of a tester. I just, if I see a problem, I'm kind of awkward about reporting it. So, let's just gloss over that. Let's not talk about it very much. What I see is an even bigger risk than that. No matter how optimistic people might be about the good intentions of people, if you are a development manager and a tester is reporting to you, and you, the development manager, are reporting to some senior level manager, a VP or a director or something like that, the temptation to suppress the bad news is going to be, from time to time, irresistible. Nobody wants trouble. Nobody wants to talk about trouble. Nobody wants to be in trouble. But sometimes trouble is a reality. And the development manager who is supervising a team of developers and a team of and a tester or 2 or 3 is powerfully incentivized to just keep the kibosh on the bad news. We'll deal with it. It's all right. So when they got rid of test managers, which this has happened in a lot of places over the course of the evolution of the Agile movement, about 25 years now. There's no direct line about what the actual state of the product is around that development manager. Right? The tester's reporting to the development manager, but not necessarily to the person above it, or not necessarily to some other line of the organization. And that means that information from testing is at the risk of being filtered and suppressed. I'm not saying that's even necessarily by intention. But you know what it's like when there's some kind of pressure on you to get something done, and there's obstacles in it, and your optimism, your natural human optimism, which, by the way, is essential for a developer. You've got to be optimistic to be a developer. You got to believe that you can solve this problem. But your belief that you can solve this problem requires you, to some degree, to suppress any kind of self-examination about what might prevent you from fulfilling that goal, or what might be a problem that you'd rather not deal with now, so we'll deal with it later, and it turns into a much bigger problem later on. So we would argue, James and I would argue, that having a person in a testing role who is reporting around the development manager is a really powerful heuristic for making sure that management is aware of the actual status of the product and not the hoped or believed status of the product. I am aware that not very many testers, because of years of marginalization, have the strength and the confidence and the skill in a lot of cases to do that really well. And that's another goal of the rapid software testing methodology, to help testers defend themselves, to be strong, not safe necessarily, but strong. And we got to recognize that nobody is going to, as Van Jones put it once in a really lovely talk, nobody's going to pave the jungle for us. Right? We've got to put on boots. And I would encourage listeners, by the way, to look that up. The fellow's name is Van Jones, and it's a short speech on safe spaces. It's consistent with our thinking and our beliefs like this. What we really want for testers is not for them to be safe. Of course, they should be they should be safe from threats and abuse and all that sort of stuff. They should be safe from that. But we want testers to be strong. We want testers to be credible. We want testers to be skilled. We want testers to be motivated to find problems that matter so that we don't inflict them on other people.
Okay, but speaking about the whole methodology, rapid software testing, so you have taught this methodology in course for 20 years right now, and during this time, can you give some examples where how the rapid software testing works in practice? When the software tester will get on the course, learn, reflect, and then put it into work.
So I think the biggest problem, one of the biggest problems, there is no one biggest problem. One of the biggest problems that we face is that people's thinking about testing, people's models of testing are messed up. I keep coming back to this notion of confirmation and demonstration as a really dangerous form of limitation on your testing. One of the things we want to teach testers to be able to do is to work without a script. To have a set of concepts, ideas, notions about how to model the product, how to make sense of your working environment, how to think about quality and problems and risks, where risks are kind of the inverse of quality, the shadow of quality. To some degree, in our classes, we teach test techniques. We don't hammer on those, though. We don't focus on those because we believe that test techniques are quite context specific a lot of the time and quite oriented towards a particular kinds of risks in particular kinds of environments. I guess that's a roundabout way of saying context or an expansion on that. One of the models that we use for developing a test strategy is one that focuses on the project environment, the context that we're working on, which includes our testing mission, who the stakeholders are, what they value, the information that's available to us, our relationships with the developers and other testers, our relationships with the equipment and tools we use, our equipment with the schedule, our mandate to deliver certain work products, whether they're material or the physical artifacts, or whether they're information or ideas. One of the things that I like to work on in the class is a recognition of a large number of ways of identifying problems. And a dominating theme in that is the notion of inconsistency. So that's all about oracles. An oracle is a means by which we recognize a problem. And a huge theme in oracles is this notion of inconsistency between what the product is like and things that are presumably desirable. And what we want to encourage testers to do, we can't do this entirely in a short classes that we do, because our classes tend to be kind of short. But we want to take testers up to the top of the mountain and show them what that looks like. So there's we have a lot of sets of heuristics and lists, and our oracles list is an example of that. If a product is inconsistent with our ability to explain it, we suspect that there's a problem here. If it's confusing, or if it's bizarre or strange, we suspect that there's a problem there. If the product is inconsistent with the way things work in the world, if it's inconsistent with the world we're trying to model with the product, the tasks and the mathematics and the languages, if the product is inconsistent with that, we suspect that we're seeing a problem. If the product doesn't work the way it used to, the product is inconsistent with its own history, and there's no countervailing reason why it should have changed, we suspect that there's a problem there. If there's an inconsistency between the product and an image that the organization would like to project, or if the product is consistent with an image that the organization doesn't want to project, we suspect that there's a problem. Now, the big popular one for most testers is, if the product does something that's inconsistent with what it says in the specification, then there's a problem here. And that's reasonable. That's natural. Although it's not clear necessarily whether the problem is in the product or whether the problem is in the specification. But we don't have to decide that as testers. That's the cool part. We get to point out, this doesn't agree with that. Management, what's right? You get to decide, management. We get to shine light on that inconsistency. We would talk about that in terms of claims, inconsistency with claims, but there are lots of claims being made about the product all the time, not just the spec, not just the requirements document, but the marketing materials, the help files, a diagram that a developer drew on a whiteboard ages ago, or just yesterday. When the product is inconsistent with anything that somebody relevant and important says about it, we suspect that there's a problem. When the product is inconsistent with products like it, and this is one of the things that, like it on some level, like it in some way. This is one of the things that governs, I notice, Oleksandr, you're an SVET, and you're probably writing a bunch of automated checks here and there to make sure that the product is consistent with that. Well, that's a great example of a comparable product. When we say comparable product, we don't necessarily mean competitive product. Like, Microsoft Word is comparable with OpenOffice. That's not, but it's an instance of that. But Microsoft Word is also comparable with the Unix or Linux WC program, word count. Yeah. What? I mean, word count is that word count. It's just a little thing. It tells you the number of words. Yes, but Word has a word counting feature. So if Word's word count and word count's word count disagree, we suspect that there could be a problem or an inconsistency here that we would like to be able to explain if it doesn't matter, or if we would like to investigate if it does. If a product is inconsistent with what users want, all the quality criteria like capability, reliability, usability, charisma, security, scalability, compatibility, performance, installability and configurability and uninstallability. And then the things that are important in the development organization like supportability, testability, and maintainability, and portability and localizability. One of the things we try to encourage testers to do is to develop their own mental models like that. Mental models of quality, mental models of risk, mental models of how to recognize problems, and apply that independently. They can adopt ours, but it's kind of like adopting a puppy. You've got to make it your own, right? You can go out and get the puppy from someplace else. That's fine. But no matter what, if you're taking on the responsibility of adopting a puppy or raising a kid, you've got to make that your own. And in the same way, our models about how to test, they have to be grounded inside the tester, literally incorporated into the tester. So there's a few others. There's if the product is inconsistent with itself, if the product is inconsistent with its designer's implicit or explicit purposes, or if the product is inconsistent with standards, statutes, laws, regulations, protocols, conventions. All of these are ways of recognizing a problem that go far and beyond inconsistency with what it says in the spec or the requirements document or a test script. And that makes testers powerful because they can apply those from their minds at any time. That's a big motivation for the notion of developing that independent, powerful testing, problem-focused mindset.
Amazing. Now I'm feeling like I would just sit and listen to all the stories from Michael because it's amazing with a lot of insights. Like I'm making some notes in my note taking right now because so many insights in this episode. Actually, when you talk about different kind of uh, I would say inconsistent things. I can remind that I wrote your article about emotion in software testing, when you can use your emotion to drive your testing. And for me, it was like maybe 3 or 4 years ago I read this article, but it for me it was huge insight that you can use a lot of different your like context from your regular life, because in our regular life we experience different kind of emotion. So you can use this, I would say it's heuristics to apply to software testing and try, okay, what if I this kind of person, or what if I in this situation, what kind of emotion I can experience with our software. And it was like, oh, okay, it's a great idea.
Well, that's great to hear. And James and I argue about this. I'm more a doctrinaire on this idea that he is. I'm more attached to this idea than James is. But the idea is, anytime I see a problem, almost without exception, it starts with a feeling. My recognition of a problem starts with a feeling. Now, James would argue, yeah, but you run a bunch of automated checks and a bunch of them run red. And so, I mean, there's that's neutral, isn't it? And my reply would be, well, no, my recognition of a problem starts with the, damn, that's running red. Wow, why? I'm confused. I'm upset. I'm annoyed that I'm seeing this. Now, of course, I wouldn't want to go too far with it, but I mapped this out several years ago, that our recognition of a problem starts with an internal, tacit, and immediate kind of response based on our mental models and our feelings. So a feeling like confusion or annoyance or frustration or impatience or surprise or sometimes amusement. I mean, you've gone through the experience where you've seen a funny bug, right? Well, when something's funny, uh, our our minds are rewarded by funny. Many years ago, I saw a fantastic lecture on what science can tell us about humor. A guy named Jonathan Miller, who himself had been a comedian, but was also a medical doctor, a brain specialist. And so his lecture highlighted this, that humor is usually based on some kind of surprise that alters our categories, that affects our way of looking at the world in a new direction. And he points out that this isn't an accident. Anything that happens around the world, people laugh when they see something funny. Anything that happens around the world has what he called a biological payoff. So a laugh is our reward for insight. I once, I remember doing this at dinner one time. I was chatting with a guy, and I said, well, a laughter is the sound that an epiphany makes. But so is, that's also the sound that an epiphany makes sometimes. Or, huh? That's the sound that an epiphany makes. Well, let's pay attention to those. Now, it's not good enough most of the time to go to a developer or to a program manager and point to the screen and go, or, ugh, or, huh? That's usually not good enough. So that's why we have those oracle heuristics, so that we can articulate the inconsistency that we're seeing that's triggering that emotional reaction. And then we can get to a set of shared feelings and mental models with our stakeholders, with our clients. The other cool thing about that is that the intensity of the emotional reaction is often a clue to its significance. If I'm really upset about something and the client is not, we need to sort that out. We need to arrive at a state of shared feelings about it. Because if my client is blasé, that doesn't seem like a big deal to me, and I'm really agitated by it, my feelings, my emotions are telling me, wait a minute, there must be something here that she doesn't know about. Or conversely, maybe she knows something that if I knew about that too, I would relax. Sorting that out, a very, very social operation, not a mathematical or logical one. Sorting that stuff out using all the different sources of information that we have available to us is how we arrive at, as a group, now management in terms of its decision-making capability, arrive at decisions about what we're going to address and what we can afford to not pay so much attention to.
Yeah, it's. I think that the using of your emotions in determining the significance of the issue is just like the thing that we need to apply more. And yeah, there are a lot of I can recall a lot of like examples from my experience when um, I just explained to the manager or to the customer that this is a problem. The risk is really high, and it can severe, so it can have severe impact on the application or on the end users. And for the person, it was not a bug, and it turned out that this particular feature that I found, this bug, is not used by anybody, or is used by really small amount of users. So if this even happen, nobody cares, or almost nobody cares. But in that case, I think we need additionally a little to do a little bit of investigation on for these, let's say, 1% or point percent of 1%, uh, what is the impact? Because if this 0.1% will, for example, for financial application, will lose the millions or billions of dollars about from this problem, then it is really serious, and we need to take
Yeah,
care of
somebody lost $1 billion, but it only happened a couple of times. Well,
couple of times in a year.
yeah,
It happens.
you lose two, three, $5 billion pretty soon. You're talking real money.
Yeah.
Yeah, absolutely. And uh, the other side of that, which I think is a wonderful story, a friend of mine, Lynn McKee, greeted me one time after a conference talk. She had seen a previous conference talk where I brought this up, the role of emotions in software testing. She she went back to her boss and she said, "I just saw a really interesting talk of this guy in Toronto." Oh, really? What was it about? It was about the role of emotions in software testing. And the guy says, "There's no role for emotions in software testing." And she said, "Well, um, I don't know. I mean, I saw this talk, and I think they actually, it could be a valuable thing to pay attention to." And the guy says, "There's no role for emotions in software testing," which is fascinating, of course, because it first of all, obviously there is a role, or he wouldn't be so upset. But also, it really highlighted the discomfort that rational, sometimes hyper rational people have with emotions, with feelings, and it has been quite a journey for me to recognize how important that is, and it's very strongly um, affected in rapid software testing by the work of Jerry Weinberg, who was very influential on me and on James. On another aspect of this, to some degree at least, was Kem Kahner's work on psychophysics. Kem was fascinated by that and did a lot of experimentation on that, showing how if testers are discouraged. Now, discouragement is a feeling, right? If testers are discouraged from reporting bugs, they won't report bugs. So there's a social aspect of that. And then that ties into Harry Collins's work. These are the three people who I would argue have been most influential on rapid software testing and how we think about things, which is this emphasis that we are humans, social creatures, that we are creatures not just of rationality and logic and calculation, but that we make decisions based on what we like, based on what we want, based on what we don't like. And like and want and what we perceive as a need and what we perceive as a desire, those things aren't strictly speaking logical. Even though, as Jerry Weinberg says, people want to feel rational. Well, let's get that straight. They want to feel rational. Who's in the driver's seat there, rationality or emotion?
Yeah, I think
Yep.
it's also additionally reminds me of this work of Daniel Kahneman about like system 1 and system 2, thinking like when we have a rational but slow thinking and emotional, let's say, and non-rational. That like in many cases we are not using our rational mind. We are driven by emotions, by social pressure, by anything, or maybe like we we have this emotion or sun is shining, we will just choose these products over another product, or we click in some other places just when nobody has clicked before or used before.
Well, I'm really glad you brought that up because Kahneman's and he didn't. Apparently, we're just as we're writing our book, taking testing seriously, due out any decade now. But as we're writing our book, we discovered something we were quite conscious of before. Kahneman didn't invent System 1 and System 2, but he sure made it clear for us. And if you like, another way of looking at rapid software testing is we want to take advantage of System 1. That's the rapid part. At the same time, using System 2 approaches to try to sharpen our System 1 kind of thinking. And looking at the interplay between those two things, looking at how they whirl around each other. And I love Kahneman's stuff on this. For example, his notion that System 1, he said at one point that the hero of his book, everybody thinks that System 2 is the one to aspire to, the one to look up to, because it's rational and it's considered and it's reflective and that sort of thing. He says, actually, the hero of my book, the Thinking Fast and Slow, is really System 1, because System 1 is at work all the time. System 1 is, from the moment you arrive at consciousness, System 1 is doing its thing, and it's consistently exhausted and it's vulnerable to being fooled. But what's System 2 doing? System 2 is sitting there with its feet on its desk, waiting for a message to System 1, help, I need you. And System 1 isn't always ready to do that because it's so dang busy. So I really liked that perspective. It's a great book. It's worth reading. The other thing I love about Kahneman is his humility, because some of the things that are in that book turned out to be very difficult, indeed impossible to reproduce. And unlike just about anybody else, certainly unlike me, when he was confronted with counterexamples or evidence to the contrary of what he found, or absence of corroborating evidence, Kahneman admirably was willing to say, yeah, well, maybe that's not right. Maybe I should drop that idea. Wow. How many people are capable of that? Not very many. We're going to miss him. He was an important guy.
Yeah.
Oh, okay. I think we need to wrap up our record. But before we finish our episode, many of software testers, I think, will be new for rapid software testing methodology. And what kind of advice would you give for them, and maybe where to start to learn more about rapid software testing and start their path in this methodology?
Well, bunch of places for looking things up. The first places to go would be my site and James's site. So in the first case, developsense.com. And in the second, satisfice.com. Satisfice is the name of James's company, and it refers to a term brought to prominence by Herbert Simon, which appears to be a sort of portmanteau, two words together, satisfactory and sufficing. A good enough kind of solution to things. That's where Satisfice comes from. There is also the rapidsoftwaretesting.com site, which is currently undergoing some redesign and renovation, because we'd like to make it easy for people to find resources and information there. There is a rapid software testing YouTube channel, which has been curated mostly by our friend Marius Francu, who is a developer in Brașov in Romania. And, along with another fellow named Stuart Watt, Marius is the kind of programmer where we want to put him in a glass case and shine bright lights on him and say, see, it is possible. Marius is that very rare a developer who is fascinated by testing and fascinated by getting to the truth of things. He's a senior engineer at Siemens, but we're looking for developers like him to come to our classes because, even though everybody is supposed to be responsible for quality and testing is everybody's responsibility and testing is everybody's job, we see a surprisingly small number of developers who are willing to lean into testing and to think seriously about it and to do deep testing. Now, to some degree, that's not a problem as long as there are testers around to do the deep testing. But in these sorts of environments where developers want to do quick, simple, and we would say not as a moral judgment, but as a warning, shallow testing for stuff that's very near the coal faces where they're working and not for deep and hidden and rare and subtle and intermittent and emergent bugs, we would love more developers to join us on that line of thinking. We want to help developers make their shallow testing deeper, and we want to help development organizations make deep testing cheaper, less expensive, less time consuming. And most of what we would do to make that happen is to get rid of things that don't matter so much. So there's lots of resources on our sites. In fact, there's a developsense.com/resources is a good place to look at some of the themes and some of the ideas behind the approach until the book comes out, which is currently slated for March of 25. So.
Okay.
Oh, great. We need to check it. But until that, yeah, we have some time to check the YouTube channel and resources.
Yeah.
And actually, for
Short
me,
stuff
it's
there
like
and long stuff, and if this turns into a video, by all means, this conversation will be up there as well.
whoa.
With your permission, of course.
Yes, of course.
We'd love that.
Yeah, good. And for me, overall, like speaking about rapid software testing, I like this methodology and idea because it actually incentivizes you to think first before just blindly applying design techniques, blindly applying tools. Because when you are using tools, you are writing automated checks and something like that, you can bring some value, of course, that's totally true, but in that case you will not find critical problems because you are not thinking like in the broad terms. Maybe, of course, maybe the curve that you will find.
You might find critical problems. You might, but you won't find surprising problems. You won't. You'll be less likely to find problems that surprise you. And I also want to emphasize this because people keep coming back to it. You guys are the guys who hate tools. You guys are the guys. You hate automated checks. We do not. Stop that. Cut it out. We love tools. In fact, we love tools so much that we would like people to think about more different kinds of tools. It's like imagine we said, there's other kinds of dogs other than German Shepherds, and they say, well, so you hate dogs then? No, we think people love different kinds of dogs for different kinds of purposes, and there are different ways of applying tools, far more than just applying automated checks. And if we thought about those, if we considered how much tooling can help us in generating data, in analyzing output from a product, in representing it in different ways, in filtering and searching and sorting, and in probing the state of the product, in collecting stuff and information. We can use tools any number of ways in testing. But the automated checks, because they're dazzling, they get all the reviews. They got all the glory. And yet, I think in many ways, they're the least interesting kinds of tooling. And that's not to dismiss people who do that work. But I think the people who do automated checks really well require a degree of skill and expertise that they could easily apply to other kinds of tool use on the product. So that there's another place, when somebody's encountering RST for the first time, one of the things they might want to look at is a paper we wrote quite a while ago. It could use a bit of an update, but the themes are still there, which is a context-driven approach to automation in testing. That helps to frame a lot of what we think about in terms of how to use automation, and some of the tools that we use in that day and age are kind of old now, but the principles are still solidly there.
Thank you, Michael. Thank you, Alexander. Thank you, me, everyone, and for sure, you listeners, and thank you for staying with us. But for sure, don't forget to subscribe, hit the like button, click the bell, and I hope you will find some insights or many insights and valuable resources from this episode. And we hope to see you again in our next episode. Bye.
Thank you very much, Jens. This has been a pleasure.
Yeah, thanks a lot. Thanks a lot for being with us, Michael. And yeah, see you at the next episodes.
And Slava Ukraine.
Oh, thank you.
Heroin
Slava.